So today I'd like to talk about how we're going to supply power to the Murgetroid itself and the LED panels. And this is important because these LEDs actually consume quite a bit of energy, or they can, if they're fully lit and at say white intensity. And that's because each of the LED positions, and there's 484 of them in the case of a 22 by 22 panel, each of the LED positions actually consists of three different color LEDs, red, green, and blue. When fully lit, each of those colors will consume 3 milliamps, which means that a fully lit white LED position will consume 9 milliamps of current. So you multiply that times 484 per panel, and you end up with quite a bit of current. In addition to that, there's a background current that the integrated circuits of the panel consume when even no LEDs are lit. In this case, it's about 323 milliamps. So if you take 484 positions and you assume there's 3 LEDs per position at 3 milliamps per LED, and you do all that math per panel, you could have as much as about 4.7 amps if it's fully lit and white. And therefore, for 4 panels, which is what the Murgetroid 3 consists of, you're talking about 17.9 amps of current. Well, we're not going to be able to supply that amount of current for these panels, and that's at 5 volts, by the way. But we can supply a good amount of current and enough to light most of the LEDs, or a good portion of the LEDs at really good brightness. And we do that using a power module here. This is a 12 volt to 5 volt power module converter, and I got this off of Amazon.com. All the parts for the Murgetroid are listed separately. But this guy takes 12 volts on its input and 5 volts on its output, and it can do it with 5 amps of current on the output. On the input side, at 12 volts, it's being supplied by a wall wart, and it's capable of supplying 3 amps of current. So that's 3 times 12, 36 watts. In the case of this power module, we can supply 5 times 5 amps, or 25 watts of current. So they're relatively well matched. In any case, this power module gets its power coming in from the base of the Murgetroid. And consider the fact that the Murgetroid is rotating. You have to ask yourself how it is that we're getting current into a rotating Murgetroid. And that's done with some very innovative brushes that I've come up with. And basically what I found is that ball bearings, at least some of them, are pretty good conductors in terms of allowing electricity to flow from the inner bearing to the outer bearing. And that means that as the ball bearing inner shaft can rotate, electricity can still conduct from the outside all the way to the inside of the shaft. So in this case, I have purchased a thing called a pillow block bearing from Amazon, and I want to show it to you here. This is the pillow bearing. It's partly mounted to the box that I'm going to mount it to, and it has a 10 millimeter wide connector to connect to a 10 millimeter diameter shaft, and the outside is conductive once again to the inside shaft. So if I connect the outside casing if I mount it with some insulators, and these little insulators here they were custom made by my friend Keith, but you should be able to use pretty much anything. This insulator is approximately 10.7 millimeters long, and it holds the pillow block bearing in place on the bottom side of the Murgetroid box, and it allows me to make this outside of the casing the positive terminal for the power coming into the Murgetroid. The negative terminal, which is also ground, will be the case of the Murgetroid, the box itself, and that will be connected to electrically connected to the shaft of the motor that's rotating the Murgetroid. And that shaft, that motor shaft, fits into through the pillow block bearing. It doesn't connect to it, it goes through it, and it connects to the mounting, the shaft mounting, which is this little hub. This is a 6mm shaft hub, universal aluminum mounting hub. It has to be drilled out for 1/4 inch. It's very close to 1/4 inch, but it's not exactly 1/4 inch. But the motor shaft, which fits into it, is a 1/4 inch shaft. Anyway, so I mentioned that the shaft fits through the pillow block bearing, but doesn't connect to it. So what does connect to the center shaft of the pillow block bearing? And that, my friends, is this little PCB board that has been modified. It's a one-sided copper-cladded board. It could be two-sided, doesn't matter. And my friend Keith has manufactured this 10mm wide shaft, and it's this little guy is I forget, it's 12.5 millimeters long, and fits into the hole that's been drilled in the PCB, and is soldered at the base to the printed circuit board. The shaft, by the way, it's got a hole in it, of course. It's a tube, and it's 10 millimeters in diameter. And that guy will fit into the pillow block bearing and is screwed onto the pillow block bearing with little set screws that are in the pillow block bearing, and therefore forms an electrical connection to the inner shaft of the pillow block bearing, which then is then connected by the ball bearing to the outside. From there, we have, I'm going to show you the actual, this is my first Murgetroid, the third Murgetroid I built. I'm building another one here. And here you can see the PCB board, and you can see it spins because the inside of the pillow block bearing spins. And connected to that is this wire, which then becomes the positive terminal. This is a power connector. I've shorted together both terminals of the power connector, and I soldered it to the printed circuit board. So this connector is the positive terminal, and we'll see 12 volts on it coming from the wall wart in the base of the Murgetroid. And then the motor shaft fits through here, does not touch, and in fact, overlaying the motor shaft, I have a small straw that I've cut to insulate, make sure that the center of the motor shaft, does not touch anything related to the positive terminal of the pillow block bearing. And that's because the motor shaft is the negative terminal, the ground. Turns out that the motor shafts for many of these motors are electrically connected to the motor body, and therefore I can use that motor body to connect to the ground. Also, it turns out that though that is true, it's also not the only way we connect to the motor shaft electrically, because it's not good enough. I found that over time, that motor shaft electrical connection doesn't necessarily stay consistent throughout the rotation of the motor. So in addition to that, and I'll show you more about this later, but in addition to that, I've wrapped some very fine braided stranded wire around the motor shaft as a connection to the motor shaft. I'll show you here. Let me get Okay, so here's an example. I used some stranded wire, and I wrapped this around the motor shaft, and then I connected this to the body of the motor. Once again, it is a ground connection. But in the future, there's probably another way to do this, and I'll be exploring that. It's going to be using a smaller ball bearing that's mounted onto the motor shaft at the very base, that I then can connect to as well. So that's how we get power into the Murgetroid. So here you see the electrical connection from the pillow block bearing. This red wire goes inside to the Murgetroid, And from there, what it does is it connects to the power module. And once it connects to the power module at the input to this V-in of the power module, you'll also want to place a 1000 microfarad capacitor across the 12 volt input. So I'm using a 16 volt 1000 microfarad capacitor, and the reason is because sometimes the little balls on the pillow block bearing, in the ball bearings themselves, don't make connection electrically to the outside, and you can end up with an interruption of power to the Murgetroid, which will cause a power on reset. So by adding at least 1000 microfarads capacitance to the 12 volt input, that small break that occurs sometimes in the power will be evened out, and Murgetroid will operate just fine at that point. So I showed you that the little PCB board that we're building here, that it basically attaches to the pillow block bearing, and it is capable of rotating. But in fact, when the Murgetroid rotates, this little PCB board is not rotating, and it's held in position by the motor mount screws in the base of the Murgetroid, and I'll show you that right now. So this is the Murgetroid base, and I want to show you here, this is the motor shaft, and these are the mounting screws. They stick through the base of the Murgetroid, and these are actually what hold the motor in place. And the little PCB board fits in between in here and is held in its position by these little posts, these mounting posts, and cannot spin as a result of that. And it doesn't need to spin, it just needs to allow the pillow block bearing to spin, and that's what those do. Oh, also I wanted to show you here, this is the little straw that I mentioned, goes over the shaft of the motor and prevents the motor shaft from shorting to the pillow block bearing. Okay, the last thing I think I need to show you is how we mount the power module that goes inside the Murgetroid box to the Murgetroid box itself. So this is the box of the Murgetroid that goes in, and you can see on the very bottom of this I've got the mounting for the motor shaft, and there's a drilling of holes that are used to mount that little hub, and the module that will fit over, it goes over those mounting screws, and it does that using Velcro. So I've placed Velcro on the back of this module. There'll be another piece of Velcro that goes over these screws that are mounting the hub, and then I can place the power module inside the Murgetroid and not expect it to move around because the Velcro will hold it in place. I think that's all you need to know at this point for the Murgetroid power, and I appreciate your watching. Thank you. A couple final notes here. I wanted to show how in the Arduino program you can set a maximum power. So here's the command in the setup of the Arduino program, and it's the fast LED set max power in volts and milliamperes. I've set it for 5 volts and 5,000 milliamperes, which is of course 5 amperes. Finally, I wanted to mention to you also on the pillow bearing that it may need to be reseated into the casing that it comes with. It's not placed in there perfectly flat, so you may need to press the bearing into the casing. Otherwise, the PCB board will wiggle up and down. In any case, I think that does it for now. Thanks for watching.